Well, hello everyone, and today in this video we'll be looking at one of the problems from Geeks for Cakes saying kth smallest in BST. The problem says to us that we are given the root of a binary search tree and an integer k, and the task is to find the kth smallest element in the binary search tree. If there is no kth smallest element, return minus 1. Very straightforward. So in this way, we have a binary search tree, and we wanted to find out the third smallest. We know the smallest element here is on the very left hand side, which is 4, which is the first smallest. Second smallest would be 8, and third smallest would be 10. But how would we get to know? One quick answer we can have is, what if we have all the nodes in a sorted manner? Lucky for us that it's a binary search tree. For a binary search tree, an in order traversal is a sorted list. So in this case, if we do an in order traversal, we would have a sorted list and we will get to know the count. So in this way, if we have in order traversal from left, current, and right, we'll have a list of all the sorted nodes. But wait a second, do we want it to have all the sorted nodes with us? The answer is no. We only want till the kth. So the moment we reach the kth node, we have to exit it. And if reached kth node, exit. Or if reached beyond kth node, don't iterate, don't go further. So this with these two things in our mind, and I'll come at the point why we are reaching at beyond kth node. Why cannot we just have a limit of a kth, but we will also go ahead and reach beyond kth node, because obviously it's an in order traversal, it's not a pre-order traversal. We'll come to that as well. But before jumping into code, let's understand the algorithm, how the algorithm would look like. So I have a tree over here, and within this tree, it's the same example from this 28 to 4. And within this example, we have k as 3. So if I'm traversing within an in order fashion, I'm going ahead with this, which is not computed yet because I wanted to traverse first left, then current, and then right. I'll go to left, which is still not computed yet because I want to traverse left, and the left of it is this. And shall I compute this? Yes, because left and right are null. So I can compute this, and the value of k instead of 3 would be 2. Note here I'm traversing in the reverse order, so k would be 3, 2, 1, and 0. So the moment we reach 0, if k is equal to 0, then the current node is target. So if I'm having k as 2, I'm coming up from left to the current. I'm taking from 2, I'm decrementing the pointer to 1, and then from current I'm moving ahead to right. The right is this. This is the right node, which is still unprocessed because we wanted to first process the left. And now we have left over here as 10. But for 10 from 1, we would go to 0. And remember, I have mentioned the thing that hey, the moment k is 0, we reach our target. So this is our target. So we found our target, which is equal to 10. But it's in order traversal. Even though we found our target, we need to go ahead and backtrack. Now here comes a twist. Over here we have process left. Now we wanted process right. So the current would be -1 because from the last was 0, now we have -1. So this is the classic point where I have mentioned that if we reach beyond the kth node, don't go further. So we are in the negative zone. That means we have already reached the target, which is correct. We don't want it to proceed further. So from this current, we won't go to right, but we would just go ahead to our parent. So the parent who called 12 was 8, and the parent who called 8 was 20, and hence from 20 we will return the target, which is 10. So far so good. Very clean and simple. So how would we do this? We can go iteratively by understanding. Uh, Sorry, we can go with the breadth first, but that would be complicated. The simple solution would be go ahead in the DFS manner and traverse in order fashion. But to keep a counter over here, we need a variable outside this stack space. So one such method is to have a variable within the class level, but I'm going to do a different way. I'll just take a variable which is not within the class, and I'll use a helper method. So it's a helper with root, and I'm using new int its array. And you know that within Java or within most of the programming languages, arrays are passed by reference. So if we modify anything within this array, it would be reflected within the all parent or child functions. So I'll pass k and I'll return the value provided from this. Or else I would just use the integer x and if, or I'll return x is equal to null, or I'll save it for the later. So my idea of having an integer over here instead of the classic is to understand this one, that what if I'm having, okay, my bad, what if I'm having 1 2 3 4 5 6 7 nodes and you are asking me to give the eighth node. Hey, I'm not having any eighth node within the tree itself. What can I return? That's the question. And in that state, I would return null. That's my solution to it. The problem demands that we should return -1, but in an ideal interview scenario, you don't need to rely upon this, because what if my tree itself contains negative numbers? What if my tree also has -1 in it? Although in this question they are not asking us, but it's better to be safe. So if x is equal to null, I'll return -1, else I will return x. And now the coding begins, where we go ahead with integer helper method, and which would be accepting root and which would be accepting the k. Now within this helper method, I'm going to first check if root is equal to null or k, which is holding the counter, is less than 0. In this case, we don't want it to do anything, we just want it to return null. Cool? Makes sense. Now what if k of 0 is equal to 0? Or else what I'll do first is I'll check, I'll have integer left and I'll iterate to helper root dot left, and within root dot left I'll just go ahead and pass k. So it would be my iterate to left. Now within in order traversal, I wanted to process current and iterate to right. So how will I process the current is I will remove the count, and if k of 0 is equal to 0, count k is 0, then it means I have reached the jackpot. I'm so sorry why I'm doing this. Okay, return root dot data. Okay, now if I'm returning the data, that's very good, and I need to also check if what if k is 0 is less than 0. In this case, I'll just return left, which I've got from my child. In that case, we are good with this. We have covered both the if statements, we have covered left, we have covered current, and now we wanted to do the same for right. So for right, I'll just go ahead and return helper of root dot right comma k. So far so good, makes sense. So this is pretty much simple. This is how we can go ahead. We have covered this algorithm, and that's how the translation within Java looks like. Let's submit this one. Let's compile this for any compiler errors. Okay, well, let's submit this. Continue with the rest of test cases. Cool. So, so yeah, it was a classic example of how binary search tree and how to traverse the binary search tree, exploiting the properties of itself, having left and right in an ordered fashion. There are many things or many ways to iterate or have a processing of binary search tree. You can know more about it by clicking the video on your right, and I'll see you in the next one.